Okay, my friends, so since we had class canceled yesterday, I'm going to go through a series of the notes we were going to do in class together yesterday. So that way you can do a kind of a connection assignment between now and when I see you again next Wednesday, because we don't have class Monday because of Martin Luther King Jr. Day. Okay, so this first set of questions, example 1, has to do with the experiment of rolling a die. So an experiment, we're gonna define these terms as we go. Experiment is just something you do and observe the results of, and we'll define the results a little bit more as we go through these notes too. But that's all an experiment is. It's in this case, it's rolling one single six-sided die. So I've got one here, and I called it a fair die, which means that none of the sides are more likely to come up than others. So you're used to these. You play them with games all the time. The results, you can get a 1, you could get a 2, you could get a 3, you could get a 4, you could get a 5, or you could get a 6. Those are the results. So what I'm asking in part A is, what is the probability that you get a 3? So probability can be defined a couple different ways, but they all kind of mean the same thing, and that's the point of today, actually. So the probability, the easiest way I think to define it, the probability of an event. Now, an event is something that happens. It's a situation that happens. So, for example, rolling a 3. What you have to figure out is how many ways can you get that event? Number of ways to get the event. Over the total number of outcomes in the experiment. Okay, let's couple terms in there, event and outcomes. So if we think about the die, it's very often easier to figure out the total number of outcomes. So for example, if I roll a 6-sided die, there are 6 things that can happen. So I know for A, the chance of rolling a 3, I know the total number of outcomes on the total number of outcomes I get is 6. The event I'm interested in is rolling a 3. How many ways can I roll a 3 on a 6-sided die? Well, if I roll it one time, just once. So the chance of rolling a 3 on a 6-sided die is 1 out of 6, which I bet a sizable chunk of you knew that already. But I wanted to make sure we define those terms over there, because we're going to use those as we go through today. All right, next question, B. What's the chance, probability, I'm going to use those words interchangeably sometimes. What's the probability or chance of an odd number? Well, odd means not divisible by 2 evenly. So still, the total number of outcomes is going to be 6 for all of these, actually, because the experiment is rolling a 6-sided die. So you only have 6 outcomes. But the event is an odd number. So how many of the, oh, that's an odd number. So is that one. So is that one. So I think there are 3. 3 out of 6. And if you want, I'm supposed to be answering these as fractions, decimals, and percentages. Let's go back to A real quick. 1/6, which if you divide 1 by 6, you're going to get 0.1666666. So we'll just do 0.167, I guess, or 16.7%. The reason I think Becky did this with this is just a practice to make sure we can actually do these things as the 3 different types of numbers. 3/6, that's a nice one. That's just 0.5 or 50%. So another way of thinking about probability, and this is an important one, and I'm going to keep saying this over and over again as we go through the recording. Probability is the rate at which something happens, and we'll see this when I do some Monte Carlo examples in later videos for today. So there's a 3 out of 6 chance because there are 3 sides that generate the event an odd number out of the 6. But another one, plant this bug in your head right now. 50% means that half the time you're going to get an odd number. If you roll dice, half the time you're going to get an odd number. If you roll dice 1/6 of the time, you're going to get a 3, and so forth. So Yes, that is the formal definition or probability, but you're going to see it's a little bit limited to things we can count by the end of the day. Okay, what's the chance we get a number 3 or greater? Okay, well, 3 or greater. That's 3 or 4 or 5 or 6. So there's four ways to get the event 3 or greater out of the 6. So that's going to be 2/3. I'm not reducing these fractions. You can if you want to. That's a half. That's 2/3. That's going to be 0.67 or 67%. I mean, I'm rounding these off to a whole number. These to 2 decimals, and that's a no decimals. This could also be 0.667. That could be 66.7. Technically speaking, this puppy dog right here is 0.6 repeating forever. So you have to round it off somewhere. So I just did it there. Okay, D. How about a 1 or a 2? Okay, so a 1 or a 2 is everything left over that we didn't account for here in C. So I'm just going to squeeze it over here real quick. So if 4 of the results were 3 or greater, that means the other 2 results, 1 and 2, are not. So that's 2 out of 6, which is 1/3, which is 0.333, repeating forever, which is 33%. 33.3% if you want to call it that, that's fine too. And this is kind of fun. E, how are D and C related to each other? Well, check it out. They're kind of, I'm going to use the wrong word first. Not the wrong word, I'm going to use a word that's not used first, which is opposites. They're opposites of each other. Now, they're opposites in the event. The opposite of 3 or greater is 2 or less. Now, I know Becky didn't say it like that. She said 1 or 2. But that is 2 or less, 2 or 1. So what you're looking at here, dear friends, are 2 events that describe opposite things. And the word for that in mathematics and probability, as you're seeing right here, is the idea of a complement. So one way to do C and D is just like we just did, which is calculate the 4 out of 6 and the 2 out of 6. Another way you could have done it was said, well, if 67% of the time we get a 3 or greater, that means the other 33% of the time we don't. So we didn't have to do all this by counting 1, 2. We could have just jumped right to the 33%. I think she has us doing one of these next in F. What's the complement of part A? So I'm going to erase a little bit up here. I think, if I can find my eraser. No, here it is. So I'm going to leave part A up there. Okay. So part A, the complement of part A, well, the event in part A was rolling a 3. So the complement is not rolling a 3. Everything else, that's F, not rolling a 3. G, what's the probability? Well, we could count, but I feel like we should just do it the complement way, which is whatever's left over. So this is G. If there's a 1 out of 6 chance you're going to get a 3, there's a 5 out of 6 chance you won't. Which this decimal is the decimal representation of that 0.167. So that's going to be what? 0.8. If I do this in my head, 33. And then that's going to be 83.3%. There you go. So, I mean, you could also, count the faces. Not 3 is 1, 2, 4, 5, or 6, but you're still going to get the same place we just did there by using that complement idea. We'll probably see that again. I haven't looked too far ahead yet in the course. Keep on reading. Try some more.